Spacetime is a fundamental concept in modern physics, central to Einstein's theory of relativity. It combines the three dimensions of space with the one dimension of time into a four-dimensional continuum. This unified model helps explain how gravity works and how objects move through the universe. In relativity, space and time are not separate entities but are interwoven into a single fabric. Massive objects, like stars and planets, cause this fabric to curve, and this curvature is what we perceive as gravity. For example, the Earth orbits the Sun not because it's being pulled by an invisible force, but because the Sun's mass has curved the spacetime around it, creating a path that the Earth follows. This concept also leads to phenomena like time dilation, where time moves slower in stronger gravitational fields or at higher speeds. For instance, clocks on GPS satellites, which are farther from Earth's gravitational pull, tick slightly faster than those on the ground. This effect must be accounted for to ensure the accuracy of GPS systems. Understanding spacetime is crucial for exploring concepts like black holes, the Big Bang, and the potential for time travel. It challenges our everyday perceptions and continues to be a rich area of research in physics. Spacetime is a mathematical model that merges the three dimensions of space, length, width, and height, with the one dimension of time into a single, four-dimensional framework. Instead of treating space and time as separate entities, Einstein's theory of relativity views them as interconnected parts of a unified fabric that shapes the universe. Imagine spacetime as a vast, stretchy sheet. Every event in the universe, like a person walking, a planet orbiting, or a star exploding, occurs at a specific point in this four-dimensional sheet. The four dimensions of spacetime include three spatial dimensions, length, width, and height, and one temporal dimension, time. These dimensions work together to create a continuum where every event is described by a set of coordinates, x, y, z, t. Einstein's theory of relativity is divided into two parts, special relativity and general relativity. Special relativity, 1905, states that the speed of light is constant for all observers, regardless of their motion. This leads to some mind-bending implications. Time and space are relative, meaning time can slow down, time dilation, and distances can shrink, length contraction, depending on how fast an object moves. For example, if you travel close to the speed of light, time would pass slower for you compared to someone on Earth. This has been tested with experiments. Clocks on fast-moving airplanes tick slightly slower than clocks on the ground. General relativity, 1915, revolutionized our understanding of gravity. Einstein proposed that gravity isn't a force pulling objects, but a curvature of spacetime caused by mass. Imagine placing a heavy bowling ball on a trampoline, it creates a dip, and a marble rolls toward it. Similarly, massive objects like planets and stars warp spacetime, and objects move along these curves. This explains why Earth orbits the Sun. It's not a pull, but the curved path in spacetime created by the Sun's mass. Here are some real-world examples.